So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about advanced modeling tools and workflows that go with those modeling tools. So, we're going to focus today primarily on the more advanced shape creation. So, if you're just getting started with Onshape, maybe just getting started with CAD in general, maybe not the best webinar for you. We're going to discuss some pretty high level loft commands and other surface type commands. Definitely important that you have kind of that core foundation of modeling already established. So the topic today, again, advanced modeling tools. We're going to work on all those, advanced shape creation techniques that you're going to need. Now, as I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions dialog in the GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and address the questions as we go through today's webinar. So let's dig in. Now, the agenda is pretty straightforward. I'm going to introduce you to the idea of advanced modeling tools and their workflows, and we're going to discuss what that means. It's a term we refer to as just a way of defining a certain set of tools. And I'm going to go through some of these tools. We don't have the time today to discuss all of them that you'll need, but I do want to go through the popular advanced modeling tools and the ones that you're going to, kind of the core tool set for creating some of these more advanced shapes. So I'm going to introduce you to advanced modeling tools. I'm also going to discuss where you might use them. And I have a few different examples lined up just to walk you through, where you might use some of these commands that we're discussing. And of course, show you examples. And as I always say with these webinars, again, ask any question you'd like. There's a questions section there, and you go to Webinar Control Panel. Feel free to ask any question, and I'll do my best to stop and address them. All right, so let's dig in. Now, what is advanced modeling tools and workflows? Well, to put it simply, it's the techniques necessary to create more advanced shapes. And generally, this is referred to as more complex contours. The curvature is very, very important in many of these scenarios. And you can somewhat classify these as more organic shapes. The things that aren't easily created using extrude, revolve, or sweep. You get into more advanced tools like loft, like fill. The combination of more advanced curves that we're going to discuss and surfaces are generally what's needed to create these more advanced shapes. So that's really what we're going to stress here today. So we're going to work on primarily curves and surface modeling tools that allow you to create those more advanced contours. Now, realize that a lot of this is very much a matter of personal opinion. Some of what I'll show you here today could be done using, other techniques. So just realize, a lot of these advanced modeling workflows definitely have some personal opinion, on how they would accomplish things. And this is just one technique for them. So that's a simple explanation. When you think of advanced modeling tools, think of the tools that you need to create those more complex contours, those more organic shapes. Now, what are those tools? Well, we're going to focus on 7 what I would consider primary tools for building more advanced contours, more advanced modeling. And really the core of them, the fundamentals of any more advanced shape is going to be the curves that drive that shape. And we have a number of different 3D curves that have been added recently. In fact, many of the commands that we're going to discuss here today have been added in the last few months. So we've really put an emphasis, a focus on creating these more advanced modeling tools and allow you to create more complex shapes. And we've really spent a lot of time trying to make it easy to use. I'm going to show you some examples of what I mean by this in a bit. But these are the 7 tools that I want to focus on: bridging curve, projected curve, composite curve, 3D fit spline, loft, fill, and enclose. Now, as I mentioned before, that is certainly not every command that you're going to need. It's just, I think, kind of the core commands that will make up any complex surface model, right? So we're going to focus on these primary tools. There are other things I could include in this webinar, things like offset surface, things like split or delete face, delete part. These are important parts of the workflow as well, but I wanted to focus on the most popular commands, the most important commands, in the hour that we have. All right, so let's dig into it. Again, feel free to ask any question that you'd like in the questions dialog in the GoToWebinar control panel, and I'll do my best to answer them as we go through things. So let's jump into it. Now, I wanted to start with the curves. As I mentioned before, I think the curves are the core, the fundamental piece to creating any of these advanced shapes, these more complex contours. And 3D curves are an important part of that. And we have a lot of different curves that have been added recently that make creating very smooth transitions very easy. And I'm going to give you a few different examples of that. And I want to start with the bridging curve. And in my opinion, at least my personal favorite of all the different curve commands we have, because it just makes it very easy to create a smooth transition between two things. And oftentimes when you think of these surface modeling techniques, it's very important to create a blended surface that matches two other things. And that's where bridging curve really comes into play. It allows you to create a curve between two selections and match the tangency on either selection. And that's really where its power comes in. This is a particularly useful command if you're trying to construct guides for a loft or edges for a fill. In both of those examples, it makes it very simple to create a curve that matches that surrounding geometry. So again, bridging curve, probably my personal favorite of all the different curve commands we have, and it makes it very easy to create that transition curve that you may need for, as I mentioned, a loft or a fill. So let me give you an example of this. I want to jump back into this road bike frame, and I want to roll back to a point in the design here. So let's go back to this split. Let's roll back to this point and take a look at how this was constructed. So if we look at the current state of the model, I have the top tube here of the bike frame, I have the seat tube here, but I do not have that transition. And that transition, that smooth transition between profiles, is a critical piece of something like a road bike frame where I'd be really concerned about smooth curvature. So this is a good example where bridging curve is a really useful command. I want to create a loft between this edge of the top tube and this edge of the seat tube, and I can certainly do that, but I need the bridging curves to give me that smooth transition, to ensure that I have a smooth transition from the top tube to the seat tube. So to create a bridging curve, fairly straightforward. You'll see in the toolbar here, drop down a bridging curve command. Right? Now, you can create just a simple bridging curve between 2 points. So if you're not concerned about a smooth transition between two things, I can easily just choose the option for match position on both and simply choose a point, right? A point here and a point over here, and I get that curve between them. It's just a simple, curve between 2 points. And if that's all you're looking for, great. You can use match position. Of course, this isn't the smooth transition that I was looking for, and that's where we get into the option to match tangent. So just below match position, you'll see match tangent, and I can choose, instead of a point, I can choose an edge, right? So I can choose this edge of the top tube. Again, choose match tangent, choose this edge of the seat tube, and it's going to create a curve that matches the tangency on both ends, right? So it's very easy to create that curve, and this curve is exactly what I'm going to use as a guide for my loft later. Right? Now you have a few things you can control. You can control the magnitude. So if I want to grab and pull on this and make it a sharper transition, I certainly can. Grab it and pull it the other way, make it less so. I can also adjust the bias left to right if I needed to kind of control the shape a little bit further. But that's really all there is to it. So a part of the reason this is one of my personal favorites is just its ease of use. It's you literally click two edges and it creates a smooth transition curve between those two. And it's very easy to construct, like in our example, a guide using this, right? So I can create a guide, a bridging curve for one part of the guide. We'll do this one more time, bridging curve. We'll select this edge and this edge. And now I have another bridging curve for the other section, the other piece of my loft, right? And so now it's easy for me to do a loft. We'll do surface, and I just select the two contours, this one and this one, and define my guides as those two bridging curves. Right. So this is an ideal scenario where I'm trying to create this smooth transition. If I just selected the two profiles, I don't get a smooth transition. I get this sharp transition between shapes. The guides that I constructed using the bridging curve give me that smooth transition all the way around. Right, so that's just one example, but I think bridging curves are probably one of the most common techniques, especially if you do this kind of surface modeling where you may be patching in between two different things. It's easy to construct those bridging curves and get that real smooth continuity without any additional effort. So that is the bridging curve command. Let's jump into the next one in my list. So the next one on my list is the projected curve command. And the key with the projected curve is you're creating a curve based on the intersection of two sketches. So if you were to imagine, if you take, one sketch profile and another sketch profile and extrude them, and where they intersect, that curve that's generated by the intersection of those two surfaces is your projected curve. Now, we've made this easy. You just select the two sketches and you automatically get the 3D curve. So you don't have to do any of the extrude or trims or anything that you would need to do later. And it's just a very simple command. You left click each piece of the sketch and you're good to go. One example of this, again, and this is very similar to the bridging curve, is if you needed something like an edge for a fill, or again, a guide for a loft where I need to be able to control the outside shape using a 3D curve and not something 2D. Right? So let's get into it. The example I have here is this toothbrush. And the toothbrush is a good example because you can see the curve that's generated on the outside is a 3D curve. Right? It moves in all different directions. And this is a combination of two different profiles, right? It's an intersection of two different profiles that gives you this 3D curve, right? So if we roll up here, let's grab this and just roll up and turn on a couple of sketches here. What we have to begin with is essentially two sketches on two different planes. Right, kind of the outside shape of the toothbrush and the 3D contour of the toothbrush. And what I'd like to do is combine them to create one projected curve. So just below, or just above, bridging curve, you'll find projected curve in the toolbar. Pretty straightforward. You just select each piece of the sketch that you want to create the projected curve from. So in my example, I select this piece, then click the second sketch section of the dialog, then click on the second piece, right? And what you end up with is a curve, a 3D curve comprised of, both sketches, right? The intersection of both sketches. So that's how you end up with a shape that, kind of wraps around in three different directions, like in our toothbrush, right? Just a simple matter of taking two different contours and creating a projected curve out of those contours, right? And that's how we get the outside profile of something like this toothbrush. So again, projected curve, the key thing there is it takes two sketches and creates a 3D curve out of them at the intersection of those two sketches. Great for, like in our example, lofts, right, as guides for a loft, or even profiles for a loft, and also edges for a fill. And we're going to get into fill in just a second. All right, so that is the next one that I wanted to discuss. That is the projected curve command. And let's jump into the next one. Question. So how did you work from that to continue the toothbrush? Well, it consisted of a couple lofts and then a filled surface for the top. We're not going to go through every example in this. We do have quite a few different examples, so bear with me. But essentially, that projected curve was used as a guide in a loft. Right? So did the bridge curve extend a straight line from one tangent line until it can fit, and then a constant radius curve? Or does it provide a variable radius curve to fit the tangent lines? Extend a straight line from one. It does not extend a straight line from one until it reaches the other. It does. I'm not sure I totally understand. It's a spline. It's not a variable radius curve. It's a spline, and it's not driven by lines that extend. Right? It's simply a spline that's. It's as if you were to sketch a spline and then constrain the ends of the splines tangent to the surrounding geometry. right? You would get a very similar shape if you did that with the spline command. So, all right. So, and by the way, the magnitude would be the amount that you extend the spline handle, right? That would give you the magnitude, the equivalent of it. All right, so the next command that I wanted to discuss is the composite curve. And composite curve, the key with the composite curve is it allows you to take what is a combination of things and turn it into one selectable entity. And there's a lot of scenarios where this is really valuable. I like to give the example of loft profiles, but it could also be used for guides and other things as well. But essentially, let's say that I wanted to loft a certain section, but I don't have a sketch. I don't have, one selectable thing that says, click this and loft from here to here. It's really a combination of entities. In that scenario, composite curve just makes it very, very simple to say loft between these selected entities and these, right? So let me give you an example of why this is so valuable. Let's jump into the spray nozzle example here. And what I have is, of course, a spray nozzle, and what I want to focus on is the modeling of the handle specifically for this spray nozzle. Now, if we go back in the design, let's roll back in the design to a certain point. This handle is really just a series of surfaces, right? Using some of the advanced modeling tools that we're discussing here, right? So just a series of surfaces. And what I really want to do is I want to enclose this back section of the surfaces, but I only want to do it up to this point, right? I want to leave this bottom piece open for another feature later. So I want to loft closed all of this. Now, if I select loft, and we choose surface here, and I left click an edge, and I left click an edge, you can see that I can go through and loft these, but I'm going to create a whole bunch of them. I need one here, and I need another one here, and that's if I'm using edges. If I'm using other things as well, I would need to create a series of these, right? So it's not really ideal. What I want is one loft that closes this entire section. So I can create a composite curve of just these three edges and then loft between those composite curves. So to explain what I mean, we'll select composite curve in the toolbar, then left click the edges that I want to define as my loft profile, right? These could, by the way, also be used as a guide. Very useful technique as a guide in a loft as well, because again, the guide needs to be one selectable entity. If your guide right now is a bunch of lines and arcs, you'll need to create a composite curve out of it to make it one selectable thing. So if I select the green, check OK, now we have a curve. You can see here in the bottom, a curve made up of those edges. Now I can use that curve to loft, right? So we'll do a surface loft between the two curves, and we can enclose that back section of the handle for our spray nozzle, right? And I'm not using a combination of lofts and doing them one at a time. I just create a composite curve of the three edges that I want, and then loft between the composite curves. So that's just one example. Keep in mind with composite curve, one of the big benefits of it is you can combine edges to other curves to sketch entities, and you can combine any combination of these as well. So it's really useful in those scenarios where, like guides for a loft or any kind of scenario where, right now when I click on it, it's only a piece of what I really need. And I need to combine all these things together to make one thing. Maybe it's one sweep path or one, like we've seen here, loft profile. And think of any scenario where you want to bring everything together into one selectable entity. That's where composite curve is really useful. And those entities can be edges, they can be curves, and they can be sketch entities, right? So that is the composite curve command. The next example that I wanted to discuss is 3D Fit Spline. Now, as the name implies, 3D Fit Spline allows you to create a 3D spline, but it passes through points that you select. That's the way the command works. So you simply click on points, and it creates a spline that passes through those points, and those points can be in 3D space, therefore creating a 3D spline. I think the real power of this, I think the benefit of this for most users out there today is the ability to define the start and end direction, because then it allows you to create a 3D spline that is matching and is smooth transition from edges of a model, right? You get that match tangency condition where it allows you to create that smooth transition. So let me give you an example of this. We're going to jump back into that spray nozzle here, and I just want to roll up a bit, right? So we're going to roll up a bit in the design of the handle here. You can see we have the general shape of the handle already created, but we don't have that bottom radius piece. And what we really want to do is create that radius, or that round section here, with a 3D fit spline, and then loft to close things up, right? So again, under the curves drop down here on the right of the toolbar, you'll see 3D fit spline. It's really just a matter of selecting points. So I can click point, 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 and it creates a 3D fit spline that passes through those points. So if all you're looking for is a spline that passes through a series of points, that's all you really need to do. Select the command, click your points, and you've got the 3D fit spline. But I think the power of this command, the ability to create that smooth transition that you may be going for, is in the start and end direction. So I can define a start and end direction and control the spline that way, right? And ensure that I get that smooth transition from a surrounding edge. Like in this example, I can left click this edge and say create a smooth transition. Now remember, you have multiple directions here, so I can flip the direction and even extend, right, the magnitude of that. And I'm going to do the same thing for the end direction. So I select end direction, select an edge, and now I get that smooth transition from those adjoining edges. So that's going to be a really critical thing as we finish off the end piece of this spray nozzle, because I want to make sure that that transition is smooth, right? It doesn't stick out, and the curvature isn't an obvious problem. So that's the key thing with the 3D fit spline. You can just select a series of points, create a spline that passes through those points. But I think the real power in the command is the ability to define that start and end direction. Really allows you to control the shape of that spline, and makes it useful in scenarios like this, where I may want to, loft to it and round out the end of our handle. So that is the 3D fit spline. Just select your points, define your start and end direction. If you want, you can also, of course, control the magnitude. One last thing I would mention is, if your goal is to create a closed loop or a closed spline, there is a checkbox option for that. So that is the 3D fit spline command. Let's move on here to our next command. Now, up to this point, what we've really focused on are the various curves and splines, right? When we go back to projected curve, bridging curve, composite curve, and 3D fit spline, these are all really tools that help you to create shapes, right? They're just the initial curves that you're going to need to create those 3D features. So what features do you need to create some of the shapes that we've been looking at here? Keep in mind, much of what you've seen today, much of what you'll see in these more complex examples are lofts and fills. And there are other commands, of course. You can use your typical revolve commands and sweep commands in certain scenarios. But a lot of these more organic shapes, these more complex shapes, are constructed using lofts and fills. I'm going to go through an example of both of these, and in particular the loft command, because I think that's the real powerful command, because it does a lot of different things. So let me give you an example of this. The first thing I want to mention is the loft command. And of course, the loft command can be used to create solid models too. So some of what I'm showing you here today could easily be done using solid modeling. But there are a few things that I always like to mention about the loft command that really allow it to do some powerful things. First off, loft with path. The example I like to give with this is the top tube of this bike frame. So if we roll back in our design here, what I want to do, let's roll back a little bit further in this bike frame design. And what I want to do is essentially I want to create a loft. And I want to create a loft between this outside contour to this outside contour. another tip, there's another scenario, by the way, where curves helps, right? Because if we look at this, this is a spline, this is another spline, another spline. So we have 4 different splines. And of course, don't want to create 4 different lofts, right? I'd rather split it up into maybe 2. And that's a scenario where I can, again, create composite curves. Here you can see I have 2 composite curves of the left and right half of this top tube. So I have these 2 composite curves. I can create a loft between them, right? So I just select the 2, and there is my lofted profile. It gives me half of that top tube. However, right now it's just a simple straight loft between 2 different profiles, right? So I'm literally just going straight from one profile to the next. What if I wanted the loft to follow a path, maybe an arc or a spline, rather than just going straight from one to the other? That's where loft with path is particularly useful. And you'll see the checkbox here for path, and I can just left click the path. In this case, you'll see it's a spline, right? And it gives it that curvature in the top tube that I would want, right? So again, just keep in mind, this functionality in other applications is found in different places. Like I've even seen it in like sweep commands and so on. But just keep in mind, you can control a loft with a path, and that's what that path checkbox does. The neat thing about this is it's very simple. You select your start and end, you select your path, it creates that transition along the path. It also creates these intermediate sections, and you can define kind of the resolution of the transition by defining more or less sections in your loft. So just keep in mind, all these intermediate profiles that you see are automatically created when you use that path option. So I didn't have to go through and create each one of these manually. All I needed to do was create that start and end, and then the spline that joins them, right? And then I have that path option. So a commonly asked question, especially if you've come from like the SolidWorks environment or other CAD applications, this functionality is in other commands. Sometimes it's in the sweep command and other places. But just keep in mind, you can loft between profiles and use a path to control that loft. Right? So that's one important thing. I think especially important if you're creating some of these advanced part models where that smooth curvature is very important. The path is going to be an important option for you. So that's just one piece. Now, the other piece of loft that I wanted to focus on is guides and end conditions. I've already briefly shown you some techniques for creating guides. Projected curve, bridging curve are very easy ways to create guides for a loft. But you can also create just simple sketch entities that define your loft or the guides for your loft. So it's really up to you. The other thing I would stress here is you can use guides and end conditions in the loft together. In the past, those were mutually exclusive. If you chose one, you couldn't choose the other. That's no longer the case. So now if you choose a guide in your loft, you can still specify a start or end condition for that loft. Right, so the combination of those really makes it, so for some powerful transition tools, powerful, I would say surface modeling tools, where matching surrounding curvature is very important. Right, let's get into. Do I have a good example? Let's jump into another example that I wanted to give here. Let's go back up to here. All right, so I mentioned loft being kind of one of the key features for creating all kinds of different shapes, and I've shown you a few different examples of that. But another example that I wanted to give is, again, this spray nozzle handle. And the reason I like to mention this is it shows you the ability to use guides and also the ability to use end conditions or start conditions depending on your scenario. There's another example, by the way, where I'm using a composite curve. Right here you can see I created a composite curve consisting of the entire edge, because by default, of course, it was split up into 2. And I want to be able to loft between the whole thing. Right, so I can choose my loft command, and we'll choose our curves here. Let's choose this, and we'll choose that, and it will create a loft between them. Now, of course, by default, when you do a loft like this, it's just going to create a sharp transition, a straight transition from one to the next. But of course, you can add guides, and I can define, this as a guide. And it's going to now match that shape. And this isn't a curve, it's just a simple arc sketch that makes up your guide. Now, one important tip for the guide command is make sure that you have something constraining your guide to each profile, either coincident or Pierce constraint. But in this sketch, make sure that you've attached the endpoints of, in this case, the arc, to each profile in some way, either coincident or Pierce. Both work just fine, but make sure it is constrained in that way. Now, I mentioned before that you can also define start and end conditions. In this case, we want our start condition to be match tangent, right? And you can see it will match the tangency of those surrounding edges. Now, this also brings up another point that I wanted to mention. I used a composite curve to create this loft. And the composite curve was essentially this edge of the model. Onshape is intelligent enough to know, although I used a composite curve to construct the loft, the composite curve consisted of edges of this face. So I can still use things like match tangent even when I'm using a composite curve as a loft profile. So just keep in mind, you can use start and end profiles with guides, and you can even use those start and end profile conditions when you've used something like a composite curve, because it recognizes this is the face that I need to match with, right? That's the face that I need to make to be tangent with. So that is, again, the Loft command. Now, this is a very high level, of course, discussion of Loft. I've actually done past webinars dedicated entirely to the topic of Loft, so if you're really interested in that, I definitely recommend checking that out. I just wanted to focus on some of the more high-level Loft techniques and things that are easy to trip up on. So again, composite curves, very useful. Also, the ability to use a guide and start and end conditions like we've done here can be very useful, right, to create and ensure that smooth transition around those surrounding faces. All right, so let's move on. Now, the Loft command is, of course, very important, but the next command that I wanted to discuss is, I would say, equally as important. And the reason I say that is because when you're using these kinds of face-by-face techniques, inevitably you're going to be left with a gap or a hole that you have to fill and you have to enclose. And this is common in any kind of complex surface modeling, but it's also common in scenarios where maybe I've imported geometry with a bad face. I import this geometry and all of a sudden this one face just looks really weird. And it's easy for me to go in, delete the face, and then patch in the face or fill in using the fill command. So I would say equally as important when we talk about this kind of complex modeling with a loft is fill. And as the name implies, it allows you to take a surface and fill in whatever the geometry may be, whatever the boundary is that you define, right? So that's really the way to think of this, is it's a surface defined by a boundary of edges that or curves that you click on, right? So it creates a boundary and then a surface out of that boundary. So that's really the key thing. Think of any scenario where I'm trying to fill this gap in geometry. The neat thing about this command is you can define continuity based on the edges that you select. So when you're doing a fill, you're going to select edges of surrounding geometry, sometimes curves as well. And you may want to say, I want a smooth transition from this edge to the fill that I'm creating. That's where continuity is important, right? So continuity can be defined for each edge that you select. The last thing I want to mention is if you're doing a fill, and the fill that you creates an enclosed volume out of a part, it will automatically convert it to a solid, so that you don't have to do this as a separate step later. And this is a common theme that you're going to see throughout Onshape. So you're going to see it in the extrude command, the revolve command, the sweep command, the loft command, the fill command. You see the screenshot up there. You can see the option to add. Onshape will automatically merge the surfaces. One of the common questions that we get asked is, where's the knit command? Well, knit happens every command that you do, right? If I create a loft and I select an edge of a part, it automatically knits the two together. It merges the two together. So just realize, that ability to merge surfaces happens as you're building features. It's more of an option inside of each one of these commands than it is its own separate command. All right, so question. Can you please provide some insight on the front part of the handle of the hose shower attachment, even if it's at the end of the webinar? Can you please give some insights in how to create the front part of the handle of the hose shower attachment? Okay, bear with me. I will stick around at the end, and we'll roll back in that model. All right, so again, the fill command, a critical part, a critical feature when we start talking about some of these advanced modeling tools. Now, why is that? Well, inevitably, you're going to be left with some kind of a hole, so to speak, that you need to fill, a something that you need to create in order to fill a gap. And again, I use the example of surface modeling in this example, but just realize that this is equally as common in importing geometry. So if you've ever imported a model and then there's just this one face that you needed to change or patch or fix, just delete the face, go in and use a fill to create a new face and blend it in with the rest of the surrounding imported geometry. So both equally common workflows. The example I have for you is this ice axe. And if we look at the head of the ice axe, this transition to create this shape is an excellent example of the fill command. So let's roll up in our design a bit here and roll back to a point where this was nothing but surfaces, right? So here we are in the model with nothing but a hollow part consisting of a bunch of surfaces. And you can see with our ice axe head that we still have a hole, so to speak, a gap here, right? We need to create a surface that kind of patches in all of these edges, this boundary that we've created using all these other lofts and things like that. So there's an excellent example where I'd use the fill command. The fill command. Now, the key thing with the fill command is you'll find it under offset surface. So in the drop down, you'll see fill, and I just choose the edges that define my boundary. So again, think of this as I'm selecting all these edges. It creates a boundary out of those edges that I click on and then makes a surface out of that boundary, right? So in this example, we'll start at the bottom here and just start selecting these edges. And I'm just going to left click on all the edges that define the boundary of my surface. As soon as I select that last edge and it finds a boundary, it will automatically create that surface to patch in the gap, right? To fill in that gap. Now, a few things that I want to stress. Let's go to a left view here. If I zoom in a bit, yes, it did create a surface, but you'll notice I do not like this transition in the surface, right? It's a sharp transition. That's just kind of the default behavior. It's not going to try and match the surrounding geometry unless you tell it to. And so that's where I would define the continuity. I mentioned this earlier, but for each edge or whatever it is that you select, remember you can use other things besides edges, like curves, for example. But for whatever you select, you have a continuity option. And here I can come in and say, let's match tangency or match curvature, depending on if you want C1 or C2 continuity. In this case, I want tangency. And what you'll see is it'll create a much smoother transition on that particular edge. And I can go through and define all of these as tangency, and it will give me that smooth transition from what is the handle of the ice axe into the head, right? You can see now if we look at that left view, I've got that nice smooth transition in the ice axe head that I didn't have a moment ago. And that's all by defining the continuity in the actual fill command, right? So again, think of the fill command as, I have this open gap that I need to fill up, and I want to make sure that it's smooth with all the surrounding edges that I select. And that's where you use fill. And you're going to have continuity options for each of these. So you could go in and define the continuity that you want, and it will give you that smooth transition that you're looking for, surrounded by a number of different edges. This is something that you simply couldn't do with a loft, at least not easily, right? So it's one of those examples where it would be a great tool if matching the surrounding faces is very, very important. And you're left with a point where I have this loft over here, and I got to have something that joins the two, right? That's really where fill comes into play. It fills that gap that you may have in your surface. Now, as I mentioned before, one very important part of fill is if you create a fill like we've done here that encloses the surface. Notice there are no other open faces on this surface. Even down here, no open faces on this. So we are enclosing this volume with our fill command. If I hit the green check, it will automatically convert it to a solid, right? So now you can see I have part 1, which is a solid part. We didn't have that a moment ago. It was nothing but surfaces. But because our fill command enclosed everything, it created that enclosed volume, it automatically did the fill. Again, this is another example where you would do this as a separate step in many other CAD applications. You'd have something like a thicken to enclose or something like that, where in Onshape, it's simply the default behavior as part of the feature. Very similar to the merge or the knit stuff that we were talking about earlier. It's simply a part of the command and not something you have to do as a separate step later. So that is the fill command. And again, the key with the fill is you're just defining the edges that you want to make a surface out of, and it creates that surface. You can match the surrounding faces to ensure you have that smooth transition you're looking for. And if you create a fill that encloses something, it will automatically convert it to a solid, so that you don't have to do that as a separate step later. So that is the fill command. Almost every one of these examples that I'm giving you here today has been used in every other example. And what I mean by that is you'll find several fill commands in the toothbrush example I was showing you earlier, or the road bike example I was showing you earlier. So these are all really popular in this style of advanced part modeling, where you're kind of creating a combination of faces and surfaces to create those more advanced shapes. All right, so that is the fill command. Let's move on. Now, the next command that I want to discuss is enclose. And enclose is pretty straightforward, but there's really two things that I want to mention here. And that is, inevitably, when you're doing all this modeling that we're doing, all of these surfaces that we've been creating, inevitably the goal is still to create a solid. That's kind of the end result of any of these surfaces. I still want to create a solid volume out of the finished, whatever it may be. So there are really two ways to do this. There's enclose and there's thicken. Now, enclose, as you might expect, takes an enclosed volume. It could be a combination of surfaces, even planes, and it creates an enclosed solid out of that volume, right? So, like you can imagine, if I just had this thing where, I have what is essentially a shell, and I just want to make it into a solid volume, I would use enclose. Now, thicken is a bit different, and I'm going to just briefly mention thicken. Thicken has been around since launch of Onshape, so it's certainly not a new command, but essentially it just allows you to select a surface and offset it with a thickness and create a solid out of your surface. Enclose is a bit different because it encloses a volume, which is another common technique, kind of the last step for many of these more advanced parts, right? These more advanced shapes. So let's get into it. Now, I do want to mention just briefly thicken. As I mentioned before, thicken is certainly not new. So just keep in mind, it's been around for quite a while. Enclose is actually relatively new. It's only been about for a few months now, but the ability to thicken has been around for quite some time. And it's pretty straightforward. You select, what is a surface, something with no thickness at all, and it offsets it and creates a thick part. Now, it differs from enclose in a few different ways. So the example I like to give is the bike frame, because in the bike frame example, it would have some thickness, but it wouldn't be thickened to a solid. Like, this isn't a solid mass inside of here. I would thicken it some to accommodate for the composite layer thicknesses, right? But I wouldn't want to enclose all of this and create a thick mass out of the bike frame, because that's not what it would be like in real life. So this is an example where I would use thicken. Right, so I choose thicken, I enter my thickness, and it goes through. You, of course, select your surface, and it goes through and grinds away and offsets all of those faces that you created and generates a solid, thick part out of whatever surface that you select. Now, as I mentioned before, this is really if you just want to offset and grab a surface and generate a solid from it. I don't want to enclose or create an enclosed volume. I really just want to offset what's already there. So if I hit the green check, here is my thickened surface, right? And at this point, I might hide that surface, and there's my solid part, right? So again, very much the last step in the workflow that you would do, but a very important example in something like this, where it's my goal isn't to enclose; it's just to offset to give it thickness for a certain material, and I'm done. Right now, so that's thicken. It's been around for a very long time. You'll find it just to the right of the Loft command, and you simply punch in a thickness, select your surface, and it thickens it. You can thicken it in two different directions. So if you want to go both ways, you can do that. But again, relatively simple tool. The next example I want to show you is enclose. And enclose is different because, again, it encloses a volume. So it's not offsetting a surface and thickening it. It's taking a combination of surfaces and just giving you one enclosed volume that makes up those surfaces. So here's an example of an iron, right? And if we roll back, well, let's go back to a point. Bear with me for a moment here. Right, so let's roll back to the enclose step. Now, what I want to do, here we have nothing but surfaces. So if we roll back to this, you can see it's just constructed using a whole bunch of lofts, composite curves, and fill surfaces. Right? You can see a number of different fills and so on. So it's really just a combination of all the things that we've been talking about so far that make up this model. But you can see I don't have, I have this big gaping hole in the bottom that leaves it open. I have this big gaping hole in the back here that leaves it open. Now, what I want to stress with this is essentially the end goal is I want to convert this into a solid part, right? All of this volume, all this, empty space here should be solid geometry, which I can then manipulate later. The way we do that is with the enclose command. Now, the thing I always like to stress is you don't have to have a watertight sealed surface, one sealed surface. You can see in our example, I have an empty hole here. I have an empty hole back here. It's not a, what often referred to as watertight surface, where it's an enclosed volume already. It doesn't have to be. In Onshape, I can use a combination of surfaces. You can see this surface is different from this surface. I can use any combination of surfaces or planes to create an enclose. So if I turn on the planes, you'll see I have this plane called base right at the bottom of the iron, and I have plane 6 right at the back section of the iron. Now, I could go in and be really meticulous and fill all these surfaces in, but it's just as easy for me to select these planes and say those are also the boundaries for a enclose, right? So, really straightforward command. You select your enclose from the toolbar, right? Then you select the surface or surfaces or planes that make up that enclosed volume. Right? Remember, this surface is just one of them. If I rotate it around, this is another part of it, and the two planes that I mentioned. So I'm also going to select plane 6 and the base plane. Right? As soon as I select something that creates an enclosed volume, any combination of things that makes an enclosed volume, it will automatically convert that or enclose it and create a solid volume out of it. Right? So again, I didn't create the fill at the bottom here to enclose this. I didn't create the fill over here to enclose this. I'm just using planes, right? So remember, combinations of surfaces, planes, both work equally well at generating those solid enclosed volumes, right? So let's do a quick section view just to prove my point here. Now you can see we have a solid volume that makes up that enclosed, surfaces that we selected and planes, right? So that is the enclose command. The question that often gets asked there is, how do I take a shell or a surface model and convert it to a solid, right? Enclosed to solid. And the answer is enclose. You'll find it again under the thicken command. All right. So those are the commands that I really wanted to focus on here today. I do know there are other commands that we can certainly discuss, things like offset surface, things like split and delete face, and all kinds of different techniques that we could go into. And we will eventually get into more of these kinds of webinars to discuss some of these more advanced modeling techniques. But I wanted to create kind of an intro into it and give you an example where some of these commands fit a certain style or workflow. And it's certainly something that not everyone will use. right? If you do a lot of solid modeling today and you don't have any need for these kinds of shapes, you may never use these techniques. But for those out there that, and maybe in the consumer products market or things like that, where, these kinds of shapes and curvature and all that is very critical, these commands are going to be important, right? The things that we've discussed here today are kind of the cornerstone of all of our, more advanced shape creation tools. So that's what I had planned. I'm going to jump back here to my slide deck. I am going to stick around and answer any questions that you have. So there's, again, a questions section in the GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and answer them before we close things out here. So I will stick around. But that's it, everyone. Thank you, and have a good day.